Hello dear students, welcome back to my YouTube channel. Please let me know if I'm audible and visible to you. One second. Okay, good Anyway, so not give any homework. Yeah, so today I will be giving you more homework, right? I will be giving you, I guess, more than 5 or 10 numericals. Okay, based on previous some topics. Okay, yesterday, na, I just forgot to give you some sort of homework. You need to just give me, na. Hello, beta. Hello, Asana, beta. You need to give me, na. Yes. Okay. One second. So let's start then. Okay. Okay. I guess in the previous class, na, we discussed about how to make a graphs between potential and a resistance if the resistance is variable. And the second one is okay. So meter bridge is a second sort of arrangement of Wheatstone bridge. It is always balanced. Okay. And the name meter bridge is given because the kind of strip is 100 centimeter long. Okay, so last class, I guess you know it, na? Yesterday or day before yesterday, we discussed these graphs. Okay, yes. If we conclude today this topic, so we will complete the meter bridge as well. There is no issue. Okay, so be in the class. We don't need to get distracted from our main topic. If time permits, we will do these topics today. There is no issue. Yes, yes, yes. I am showing here. No, I came here to give you everything which is needed for your NEET examination and JE1. So I will be giving no. Without numerical physics is nothing. Okay. So we were discussing about cell case. So if we are talking about the cell structure, so we are having some cases. We are having some cases. So we need to discuss about case number first. Case number first in cells. Okay. Okay. Look now. First case is when my cell is discharged. Okay, I can write here discharging of cell. How you will label it your cell that it is discharging or it is charging. If we have my structure, now look, it is my external resistance with my battery or your cell with your internal resistance. Okay, the dotted line represents your structure of cell. Okay, with your EMF E, internal resistance R, and the external resistances R. If the current through the circuit is I. If the current is I. Suppose now, what we can do now? If this point is A, suppose now, if this point is A and this point is B, now extract this portion. Can I just write it like this now? Point B, R, E, point A, and I have given you this topic now. If I current is leaving your circuit, I current must get inside your circuit. This thing we discussed in the previous classes. If your battery is giving I current, it needs to get I current inside. Okay, now use my potential. We discussed this thing now. So I will write potential at B. Look, potential at B. Okay, sir. We are going with the direction of current. So my potential is minus. Potential across this R will be minus IR. Potential across this E will be plus E. Potential at A will be VA. So what I can write here? I will write here VB minus IR plus E equals to VA. So therefore, I will write VA minus VB equals to E minus IR. Done? Done? So this equation indicates that if we are dealing with the discharging case, if we are dealing with discharging case, so in this particular thing, my potential, terminal potential difference will be less than my EMF. Okay, this one, no? My terminal potential difference will be less than my EMF. And whenever in your question it is given it is discharging case, so you need to write this equation. Now case number second. Case number second. Case number second is charging. Case number second is charging. Look now. We have same circuit now. Same circuit. Now if we are dealing with charging case, in charging, what is the difference? What is different? So we can do one thing now. I will place here big battery. Done? So what will happen? This battery will push the current inside your small cell. You can see from here now, if this is point A, this is point B. What you will see? Sir, current is going inside my cell. If current is leaving cell, that is discharging case. If current is going into from the positive terminal, that is charging case. So you can see this one is charging case. Now you can see here now, and you will write the equation now. I will write VA. VA. Look, the potential of this one is VA. Potential of this one will be minus E. Current I, here is current I, okay? Potential of this one would be minus IR. Potential of B will be VB. So VA minus E minus IR equals to VB. So you will write VA minus VB equals to E plus IR. It is E plus IR. So you need to get this thing now. So if we are dealing with discharging case, so this equation we need to use E minus IR. If we are dealing with charging case, so we have to use E plus IR. So you can see from this one that my V would be more than E. From the equation, in charging case, my terminal potential difference is more than EMF, electromotive force. Now, as you can see here, suppose case number third. Okay, let us discuss now case number third. Case number third. Case number third means if we are having an open circuit. If we are having an open circuit. Open circuit means current is neither leaving nor entering. Okay. So you can write what? Open circuit means no current. No current. I am going a little bit slow. Okay. If this key is open now, if my key is open, you can see no current will flow. Why? Because circuit is open. It is not completed now. So here I is 0. I is 0. Now look, this is point A. This one is point B. Write the equation formula once again. I will write VA. Okay. Minus E. Okay. Minus I. I is how much? It is 0. 0 into R equals to VB. So I can write VA minus VB equals to E. So in my third case, my terminal potential difference is equals to E. Okay. Interesting case, no? So you can write V is equals to E. So you can frame your question now. We have three conditions now. Three conditions. First condition is discharging, where my E is more than E, where my E is more than V. So we have to use the equation delta V is E minus IR. Second one is my charging case, in which my current is going into my positive terminal of my bad cell. Okay, so you will write V equals to E plus IR. That means V is more than E. Third one is my open circuit, in which my current is 0. In this particular case, my terminal potential difference will be equals to my EMF. Now, let us discuss now some numericals. Some numericals, okay? We have to discuss some numericals, no? Numerical number first. Language of numerical. The internal resistance. The internal resistance of SL of EMF 2 volt is 0.1 ohm. It is connected to a resistance of 3.9 ohm. The voltage across the cell will be, okay. Yeah, in yesterday's class, I have given you the derivation of Wheatstone bridge, no? I guess by using KVL, I have given you the derivation of that Wheatstone bridge. By taking two equations, then we divide those equations and we got to know na P by Q, R by S, or R1, R2 equals to R3 by R4. Now solution. What is given to us? Sir, the internal resistance. So my small r is given to me. It is 0.10. Okay. Sir, EMF. So E is given to me. It is how much? It is 2 volt. Capital R is given me. It is 3.9 ohm. I need to find out V. If nothing is given now, okay, if nothing is given, which one? If nothing is given, what we need to just take it as a discharging case. So what is discharging case? So delta V equals to E minus IR. Then we need to find E. E is how much? It is 2 minus I. What is R? Sir, small r is 0.1. It is 0.1. But we don't know I. No? For I, do you know the equation I is equals to E divided by R plus R? We discussed this equation yesterday. Yes. So E is how much? E is 2. Capital R is 3.9. and small r is 0.1. So I is equals to 2 divided by how much? 4. 2 ones are 2, 2 twos are 4. It is 1 by 2. 1 by 2, na? So I can write V equals to 2 minus 1 by 2 into 0.1. Done? Okay, so I can write V equals to 2 minus 1 by 2 into 1 by 10. 2 minus 1 by 20. So I will write how much? It is 40 minus 1 divided by 20. So it is equals to 39 by 20. Clear? So V came out to be, if it is 40, so I can write 2, but it will be somehow 1.9 volt only. Easy, no? Very easy calculation, okay? We don't need to just make it tough for our side. Very easy. And don't rush if you are dealing with any numerical, and if the numerical is given in the word format, just like the same, my internal resistance, you need to write it is in the symbolic forms. So I have written the whole thing in RERV. Now once we are writing this thing now, we will get the idea of equation that we need to write. Whenever you are writing any numerical solution, just decode the whole numerical into its symbolic forms. When you are seeing the symbolic forms, you will get recall all the previous equations. Then you can get it now. Look, what I did now, I write here RERV. Then I wrote this equation. Okay, from this equation, I got to know that I is missing. Okay, if I is missing, how many formulas we are having to get I? We have one formula, which gives E, R, and R. So I get R, I put the I value, I got my V value. Okay, next numerical. Okay, next numerical. If we are having something like this, look now. Then 10 volt, 1 ohm, 4 ohm. We have to write V. We need to write V. Sir, how to write V? How to write V? Okay, clearly you can see now there is only one potential source, this one. So obviously now this one is a discharging case. This one is a discharging case. Why? If it is a charging case, so there should be a one more battery, right? If there is no battery, it is a discharging case. For just discharging case, my delta V equals to E minus IR. Simple. What is E? E is 10. It is 10 minus I. I we don't know, and I is 1. Now I need to find out I. So what is I? Sir, I is E divided by R plus R. E is 10. R is 4. This R is 1. So I need to write it as 10 divided by 5, which is equals to 2 ampere. So can I write here now? It is 10 minus 2 into 1. So delta V or V came out to be, it is 10 minus 2, which came out to be, it is 8 volt. So it came out to be 8 volt only. Easy, no? Yes, 8 volt is the answer. Am I lagging? 1 second. Mine is good. It is 8 volt. Okay. My network is good, na, but I don't know why is it lagging. Okay. One numerical from your NEET. So we will discuss the NEET PYQ. Numerical like that we are having a system like this. Look now. We are having two cells. These are my two cells. Okay. With same value. If this one is E, this one is E. Internal resistance of first one is R1. Internal of second one is R2. And this one is R. Okay. And R1 is more than R2. This thing is given to us. R1 is more than R2. And if potential across this one, if potential across this one is V, and the value of this one is 0, then find R. I will read the whole numerical. We have two batteries with same EMF and the internal resistances R1 and R2, where R1 is more than R2, with external resistance R. If the potential difference across the first cell is 0, then find external resistance. Okay? No better. It is not like that. How to do this one now? Huh? What we can do now? Look, let us use KVL. Okay, first step, let us use KVL. If we will use KVL, so current will flow like this now. If I current is flowing, I current is getting inside the resistor, I current will go through this one. Okay, the same I current will flow throughout the circuit. Okay. Now what happened here? KVL. So I will write IR. Okay. Okay. So I will write IR. I is I. R is R. Done. Then potential difference, it would be positive. IR. Then I current is flowing like this. I current will flow like this, right? Yeah. Plus E. If we can go like this. Okay, we can do one thing now. We will start from this end. There is no issue. We'll start from this end now. It will be easy for us. So it is minus I R2 plus E, then minus I R1 plus E, then it will be minus IR equals to 0. Yeah, current is going now. We are taking it like this now. Clear? So look, E plus E 2E. It came out to be 2E. So minus. So I will write 2E equals to IR plus IR1 plus IR2. I can write 2E. I will take I common. Then we are having R plus R1 plus R2. So what I will write here now? I will write here I came out to be, it is 2 times E divided by R plus R1 plus R2. One equation of current from the above circuit. Done? Now, question is given for this one now. So I will take it 1 point. I will take it as a 1 point and this one is a second point. If this one is A, this one is B. Clear? So I will write now VB minus IR1, okay, plus E. equals to VA. So VA minus VB equals to E minus IR1. I can write like this now? Yes, sir. Done? And it is given that this term is 0. It is given that it is 0. So I will write 0 equals to E minus IR1. So therefore, E came out to be IR1 E. I is how much? It is 2E divided by R plus R1 plus R2 whole multiplied with R1. Now this E and this E get cancelled out. So what we have? We have R plus R1 plus R2 equals to 2R1. So I will write R came out to be 2R1 minus R1 minus R2. So therefore my R came out to be it is R1 minus R2. And this one is my NEET PYQ. An easy one also, okay? Done, beta? Easy? Look now. Suppose we have now couple of cells. We have now couple of cells. Done? These are my cells. With R. No, basically now look, when you are seeing some optional, let us suppose now in upper case, why I manipulate the value of capital R in terms of small r1 and r2? Because my options which are given to me now, options are very relevant to this. So my options was r1 minus r2 by 2. Second was r1 plus r2 by 2. Third one is r1 minus r2. Fourth one is r1 plus r2. So my question wording and the options are giving me a clue that how you need to proceed in this numerical. Okay. So look, you can see now this one is a series case. Series case. So if let's suppose this is E1, R1, E2, R2, E3, R3, En, Rn. So how you will write the equation now? Huh? How you need to write the equation now? Any idea? Yes, sir. So I will write E equals to E net divided by R net. Clear now? You can see now, look, we are having R. So you can write R1, R2, R3, R4, R5, so on. So you will write, how you write? Sorry, you will write E1 plus E2 plus E3 plus so on up to En whole divided by R1 plus R2 up to so on up to Rn. You need to write in this way. Okay, easy now. If let's suppose one more topic, if E1 equals to E2 equals to E3 up to so on equals to En equals to E, and R1 equals to R2 equals to R3 equals to Rn equals to R. So how you will write now? You will write E net came out to be N times E divided by N times R. It will be E by R only. Yes or no? Uh-huh. But here is one more R, na? R plus NR. So you write R here. No, it won't get cut now. What you are telling me now? It won't get cut now here. It will be R, na? So it will be NE divided by R plus NR. You are saying yes, sir, right? Done. And look here, you can see the polarity of each and every cell is same. Polarity, right? Look, positive one is connected with negative one. This positive is connected with this negative one, and so on. If now, let us suppose the polarity is different now. If polarity is, if polarities are different now, if polarities are different, so what you need to do? You need to put value of E with sign. Suppose one battery is in this way and second one battery is in this way. If it is E1, E2, and if E1 is more than E2, what you were right? You were right. It is E1 minus E2. It would be E1 minus E2. Okay. You can write E by R only in case my R, capital R is 0. If capital R is 0, so you can write E by R only. Now we have now some cases. Now we have some cases. First case is known as parallel combination. We are having parallel combination. Parallel combination. Okay. One cell, second cell, so on up to n number of cells. These are n number of cells. N. So it is E1, R1, E2, R2, En, Rn with a external resistance R. Now, how you will write this answer? Sir, my E net will be equals to E1 by R1 plus E2 by R2 plus E3 by R3 up to so on whole divided by 1 by R1 plus 1 by R2 plus 1 by R3 plus so on. Okay, done now. So why this one? Because you know that what is R net now? 1 by R net. So let us have a very specific case now. This one is general, na? But a specific case where we only have two cells, only two cells. How to manipulate with my numerical if we are having only two cells? Look now. And you need to memorize this value. You need to memorize the whole value. R E2 R2 E1 R1. Okay. So how you will write E net now? What is E net now? Sir, E1 by R1 plus it is E2 by R2 whole divided by 1 by R1 plus 1 by R2. So I guess I will write E1 R2 plus E2 R1 whole divided by R1 R2. Then we have R2 plus R1 divided by R1 R2. Cancel out. So my E net came out to be E1 R2 plus E2 R1 divided by R1 plus R2. This value you have to remember. Okay. And the value is same to that of what? Do you remember? Alpha series and alpha parallel. Huh? Do you have anything? Alpha series and alpha parallel? Look now. Now we are having if let's suppose now this case. One second, what happens to it? One second, better. Okay. Look now. You can write here E1 equals to E2 equals to E3 and so on equals to E. And R1 equals to R2 equals to R3 and so on equals to R. Then what was the formula for E? Sir, E was equals to E1 E net now. It was E1 by R1, E2 by R2 and so on divided by 1 by R1 plus 1 by R2 plus so on. Okay. So I will write now E by R plus E by R up to so on whole divided by 1 by R1, sorry, R only, no? 1 by R plus 1 by R and so on. So I will take E common, then what we have? We have 1 by R plus 1 by R plus so on whole divided by 1 by R plus 1 by R plus so on. You can see I will cut these now, this one and this one now. So in this case, my E net is equals to E only. Let's suppose if we are having hundreds of cells joined parallelly to each other with same EMF, what will be the resultant EMF? That will be only E. And what will be R net? What will be R net? Sir, it is R by N only. Same as the Ohms law R, no? Previous one. Okay, because one by how, sir, it is how you will ask me how it is 1 by, because 1 by R equivalent equals to 1 by R plus 1 by R plus so on. So you will write it how much? It is N by R, 1 by R equivalent. So R equivalent is R by N only. Done? Okay. So now let us discuss these two cases, no? For a quick recap. So we discuss series now. We discuss parallel now. So what do you write? What is E net? If we are talking about 2, E net is E1 plus E2. We sign. What is R net? R net is same R1 plus R2. If same E, that E1 equals to E2 equals to E, and R1 equals to R2 equals to R. So my E net is equals to N times E, and my R net equals to N times R. Done? But here E net. So E net is how much? Sir, it is E1 R2 plus E2 R1 divided by R1 plus R2. And what is R net? It will be R1 R2 divided by R1 plus R2, same as the parallel case. Okay. If same, so you will write E net equals to E only, but R net equals to R by N only. This value you need to keep in your mind. Done? So these things should be in your mind, how to write these things. Okay. Okay. Take a screenshot of it now. Done? Derivation of what? Look, this derive, if you can see your NCRT now, this derivation is given in your NCRT. Okay, and it is not that important for examination. But if you want the derivation, you go to your NCRT to page and you will find it. It is very easy. It is not that difficult. It is given in pages, no? Nobody will go to ask you to derive the series and parallel combinations. I know that if something is very important for an examination, I will show that. There is no issue. Look now, one numerical, okay? One numerical. I will write the numerical. And you need to tell whether you need to use the charging case or discharging case. A car battery. A car battery of EMF 12 volt and an internal resistance 5 10 to power minus 2 ohm. Receives a current of 60 ampere from external source. Then terminal potential difference of battery is. So what is given to us? Look here, a car battery. Okay. Look now, a car battery of EMF 12 volt. That means E is given us 12 volt. Okay. Internal resistance small r is given us 5 into 10 to power minus 2 ohm. Okay. receives a current. That means if this is your battery, it receives current. So I guess this particular case is what? Discharging or charging? Sir, it is charging case. And if it is charging case, so you will write V equals to E plus IR. And current is how much? 60 ampere. So we have to find out V. Clear now? Okay. So which equation you need to use? Sir, we know that V equals to E plus IR. We need to find out E is 12. I is 5 into 10 to power minus 2. No, it is R. No? Okay, I will write 60, right? Look, so I will write 12 plus 6 5 are 30. It is 300 10 to power minus 2. These two cancel out. So V came out to be, I guess, 15 volt. Yeah, charging, na, 15 volt. Okay. Next numerical. Next numerical. So being the class now, we will be starting the meter bridge also. We will be starting meter bridge also in this class. Okay. Okay, next numerical. Look now. Okay. Now what we have? We have cells connected in series. Each and every one is having same value. Okay, these are n cells, n cells. Now we connected or short circuited. We connected it now. So we will do what? Short circuit. Short. That means we connected the end pointers with our wire. We connected the whole thing with a wire. It is short circuited. Oh, what we can do from this one? What is I now? What is I? Sir, one formula that we know that I equals to E net divided by R plus R net. Okay. What is E net? Sir, if we are having n number of cells, so I can write NE. These are in series. R is 0, no R given. So what is R? It will be N times R. So I guess my answer is NE divided by NR. N net cancel out. So my I came out to be, it is E by R. R is 0. So now if somebody will ask you, make a graph out of it. Graph. Graph between N number of cells and current I. I guess my graph will be straight line graph. Do you know why? Because my current is, so you write current is independent on N. Current is independent on N. Okay, the second case will be my parallel case. Okay, which one is second now? Second one is my parallel case, and that is if we are having cells. If we are having n number of cells. N number of cells, okay? N. Now we short circuited. We did what? A short circuit. Short. ER. ER. So what is E net? It will be only E divided by R plus R net. E is E, R is 0, and R net would be R by N. So my answer came out to be, it is NE by R. So you can write E net is equals to NE by R. Sorry, it is not E net, it is I, no? It is I here. So it is I. So you can write I is directly proportional to the n with power 1. So if you need to make a graph of it now, between n and I, it will be a straight line from the origin. It will be a straight line from the origin. Done? Any issue now? Any issue, beta? Okay, so how many topics we have done so far? 1 second. 1 second, beta. So we done this topic also. Charging battery, discharging one, V and I. Cells we done. Battery we done. KCL, KVL, Waystone bridge. Okay, Waystone bridge we done these things. Okay, done. No, no, 12. 12. It is not 10:30. Not 10:30. Today we will complete great topics. Now we will complete. Wait, no, we have completed that. I will be showing you some Waystone bridge problems, then extension of Waystone bridge, right? Then we will discuss the meter bridge also. If time permits, we will discuss the heating effect of current also. Okay, that is the numerical then. One numerical. These are some homework questions for you. Some homework questions, beta. And I want you to do this numerical, okay? Hasna, you too. 8 ohm, point A, point B, 7 ohm, 4 ohm, 10 ohm, 3 ohm, 6 ohm. Okay. Second numerical. Second homework question. Done. 1, 2. Now third one. A point B, 10 ohm, 20 ohm, 30 ohm, 20 ohm, 40 ohm, 60, 5 ohm, 5 ohm. Done. Okay. Complete. You can do no. You can do numericals. Okay, you can do it. Look now, we have couple of numericals. We have couple of numericals. Okay, so do you want some tough numerical as well? Do you want some tough one as well? Huh? Do you want some tough one as well? As you know all these things, huh? Do you want some plus one as well numerical? So I can do one thing now. For your happiness, right? I will be giving you one numerical, a good numerical. Okay, I will write here 10 identical 10 identical cells connected in series are needed to heat a wire of length 1 meter and radius r by 10 degree Celsius in time t. In time t. How many cells will be required to heat the wire of length 2 meter of the same radius by the same temperature in time t. Okay, if you okay, you told me that you need some great numerical, so this is one of the great numerical in which you need to just connect the thermal physics with this particular chapter. Okay, delta q ms delta t, right? Okay, look now, I guess you are done with this one. Now start next topic known as meter bridge. This one is not for NEET, you will write it for JEE. Okay, good one, no? So you need to just find the relation of L. If L is changing, what will be the effect of R, and what will be the effect of next length with respect to R, right? Temperature difference is same. What will be the mass effect now? Mass is also there, no? And you will get mass effect by density, volume. It's your homework. Okay. Next topic is meter bridge. This one is meter bridge. Meter bridge. What is meter bridge? Meter bridge is a type of equipment which is also needed, we use now to get the value of unknown resistor. Okay, so you can say now it is one more form of Wheatstone bridge. It is a balanced Wheatstone bridge. Well, this one is homework now. The shadow is homework, right? And as my student knew that if today I am giving some homework, tomorrow with the starting of my class, we are discussing the numeric. Done now? Look now. So meter bridge looks like this now. Look, beta. Which crown? Which crown, beta? And this meter bridge experiment you are having in your school now for your board examination. This one is present. Okay, look now. This one represents my cell. This one is key. And this one is my 1 meter or 100 centimeter long wire or a strip. Okay. Here we have one resistor. Here we have one more resistor. Suppose the value of first one is R. Suppose we know it now. We know it. Known value. We know it. The value of this one is X. Unknown. Unknown. This one is unknown. Okay. So with the help of this meter bridge, what we can do now? We will find what should be the value of X. How? We will connect a galvanometer. We will connect a galvanometer here. Okay. A galvanometer. This one is my galvanometer. And in front of galvanometer, we are having a jockey. A jockey. Jockey is sort of pen, okay? It is sort of pen that we can just, what we can do now? We can take the jockey. We can take the jockey and we will place the jockey at different types. Look, if we are placing it here, we are closing the key. We are closing the key now. Now I put the jockey here. I put the jockey here. This galvanometer shows some deflection. That means the current flows through the galvanometer. Now in second part, what I do now? I place the galvanometer here. I place the galvanometer here. Still, this galvanometer shows some deflection. Now in third case, I pointed the galvanometer here. Once I touched the galvanometer here, no deflection. No deflection. No deflection means no current passes through galvanometer. Okay. Look now, we know that, sir, if we are having a wire and we are connecting this wire to some different wire. So what you will notice? You will notice the current will flow through it. Now, by somehow, when we are touching here, no current flows through it. If no current flows, then means potential difference is same. Potential drop is same. Okay. So you can say there's a potential at this particular point and potential at this particular point will be same. And suppose the length of this particular portion is how much? L. So what should be the length of this rest part? Sir, this will be 100 minus L. This one would be 100 minus L. If the length of this particular part is 100, this will be 100 minus L in centimeters. Now look, we will define some parts, right? If sigma is resistance per unit length, Sigma is resistance per unit length. It is resistance per unit length, right? That means in 1 centimeter, we are having sigma resistance. In L centimeter, we are having sigma L resistance. In 100 minus L centimeter, we are having sigma 100 minus L resistance. This part we know. Now, what also we know that if we are saying, sir, no deflection, when deflection in galvanometer is zero, when deflection in galvanometer is zero, so you will write it is balanced condition. It is balanced condition. It is balanced condition. So if it is balanced, now look, we can just recall the Wheatstone bridge. Okay, we can recall it. If it is R1, R2, R3, R4, either we can write R1 by R2 equals to R3 by R4, or we can write R1 by R3 equals to R2 by R4 by rearrangement. That means left two terms and right two terms. Ratio will be the same. Done. So here left term, now we are having here R, we are having L, right? We are having unknown X, then we are having 100 minus X. So I can write the equation R divided by sigma times L equals to X divided by 100 minus L into sigma. Sigma cut out, so you can write in meter bridge that R by L equals to X divided by 100 minus L. So this one is my relation of Wheatstone bridge, which is similar to what? This is a relation of meter bridge, and this is same to as the balanced Wheatstone bridge. Balanced Wheatstone bridge. Clear? Done? No? Nothing tough. So you can write left two terms ratio is equals to right two terms ratio if the deflection in galvanometer is zero, shunya. Let us do a numerical on it now. A numerical from this one. Numerical. And numerical is like, look now. Look. I need to make it now. Okay. Then we are having a jockey here. Jockey touched it in 40 centimeter. So fine. Okay, so this length will be how much? 60. Okay. Now, if by somehow we place one more resistance here, one more with value 12 ohm, with value 12 ohm, find S value. How we can do it? Look now. First case, this one won't be there now. So what we can write? Sir, we will write R by 40 equals to S by 60. First equation. When we place a resistance one more here, so it is null point gets changed now. It is null point get changed. null point means where deflection is 0. So this particular length came out to be 64 centimeter. If this is 64 centimeter, so this one could be 36 centimeter. Second equation. So I will write how much? Sir, R divided by 64 equals to, look now, here in first case it was only S. Now we are having parallel. So I can write S multiplied by 12 whole divided by S plus 12. So I will write how much? 12S divided by S plus 12 whole divided by 36. Now divide these two terms. S cancel out, R cancel out. So what we have from this one? We have 64 divided by 40 equals to 1 by 60 whole divided by 12 by S plus 12 divided by 36. So we have 64 by 40 equals to 36. 1 second. No, 1 by 60. Okay, it is yeah, 36. 36 divided by 60 into 12 divided by S plus 12, right? It is given now. Look, when we place 12 ohm resistor here, so my deflection point, my null point gets changed to 64. It is given in question. It is given in. I think we are doing some wrong things, no? So let us not go with this kind of thing. Let us just solve it. So I will write it 1 by 60. 1 second. It is 1 by 60 whole divided by 12 by S by 24. 1 second. It is 1 by 36. Yes, it would be. So I can write 1 by 60 multiplied by 1 second. I get it S plus 12. It is 36, is it? No? 36 divided by 12. So 1 cancel out. 4 1s are 4. 4. 6. So we have 16 into 12 divided by 36 equals to S plus 12. Okay. So I can write it like 1 is 3. So what we have S equals to 16 by 3 minus 12. S is 16 minus 36 by 3. It came out to be negative, no? But negative is not correct. I guess we are doing something wrong here. Look. We are doing something wrong. That's why we are getting negative, no? Negative is not the correct one. It's not the correct one. So it is cancel this point. Where is 6? Which one? 1 second. Which one you're talking about? 60, no? This is 64. This one is 40, no? Okay. So it is 64 by 40. Okay. 1 by 60 whole divided by 12 divided by S plus 12 multiplied by 1 divided by 36. 1 second. Okay, now 12 1 are 12, 12 3 are 36. Done. So we can write 64 by 40 equals to 1 divided by 60 whole divided by 1 divided by 3 times S plus 12. Now, is it correct now? Okay. I get 64 by 40 equals to 1 divided by 60 multiplied by 3 S plus 12. 3 1 3, 3 2 6, 0. 0 0 cancel out. So I can write it 2 on the 2, 2 to the 4, 2 3 the 6, 2 to the 4. So it is 32 equals to S plus 12. So S came out to be 32 minus 12. S came out to be 0, 20, 20 ohm. Is this correct now? Huh? Is this one correct now? 20 is awesome, no? Okay, so 47. So let us give you some more numericals. I will give you some couple of homework numericals now, okay? More, okay? So we have given you 3, now more numericals. Then we will end the class. One ohm, 2 volt, Q, 4 volt, 1 ohm, 5 volt, 1 ohm, 10 ohm, 10 volt. P. Done. Vp minus Vq. You need to find this one now. Clear? One more. One more numerical, okay? One more now. These are some homework questions. You need to do it. Yes, V initial plus minus potential difference across the line equals to V final. This one is also one numerical. Okay, one more. Done. One more from NCRT. Each side represents R resistance. Find VA minus VB. Okay, VA minus VB. You need to do this one. Homework numericals. And tomorrow, this one. Take a screenshot, no? Take screenshot. The shadow beta, I have given you time, no? Look, if you are not solving numerical by giving some try, okay? That won't help you in understanding any topic now. Give it a try, okay? Give it a try. Tomorrow, same time in 10:30, I will be here, no? Which one? The temperature one? The temperature one? So what we can do now? Tomorrow, we will start power and heat. Numerical number, this is cube, na? It's very simple. Okay? Very simple. This one is from NCRT. So this one, extension form of Wheatstone bridge. No, tomorrow power and heat, na? It is from this particular chapter only. It will take more 2-3 lectures. Then we will start the new chapter. In this particular week, we will start next chapter. Okay? But I want you to just repeat, revise each and everything. You're having, no, look, Q1, this one is unbalanced. This one is unbalanced, okay? Unbalanced. Wheatstone bridge. This one, you can see it is a, look, one hint I will give. If I current is flowing through this one, I current should get inside it, no? If let us suppose current, this one is giving some current, let us suppose I, okay? So through this one, my I 1 ohm will be 0. This is your hint. This one is your hint, okay? Potential at, it's easy, no? Potential at P and Q. It is very easy. What? Sir, potential at P minus IR, okay? Or plus IR. Then you will go, it is 0, then plus 5. Then you came here with some value. So you will write KC, you will write KVL for this one. You need to write KVL for this one. And you need to write potential from this particular part to this particular part. Tomorrow I will show it, no? Okay? Tomorrow you will get the reason also, beta. I guess you are new in the class. Shadow beta, you are new in the class. I guess you are new in the class, no? Okay. And one more thing, na, you have the, if you can check the description part of my channel or this video, you will find my Telegram link. After completing the chapter, I am uploading my material to the Telegram channel. If you want the material, you can just join Telegram channel and you can get the mind maps also. I guess why current in middle is 0. I guess in yesterday, na, good vibe. I guess yesterday and Hasna, yesterday we have done the same numerical why the in middle current is 0. Why? Because if your battery is giving I current, it needs to get I current back into it. Na? So there is no way that the middle one is getting any current. But I don't know. Na? I guess there is some points of it. I don't think what is this XP. I don't have any idea about it. I am new to this YouTube kind of thing. Na? I don't have any idea about this crown, how to get this crown, the one, two, three, four. I don't have any idea. Yeah, Hasna is getting, no? Hasna is also getting the crown one plus one, the hashtag one. I don't have any idea about it. Okay. So we have 1 2 minutes. If you have any, if you want to share anything, you can share now. If not, then bye bye. Good night. Take care. Yes. Yeah, beta, I know it. So what we can do now? Magnetism. Look, this particular chapter will take, I guess, 3 lectures. Okay, 3 it will take, because we are doing some numerical practices and we are not taking some. Look, in my classes, I am not defining any term in a very great way. Why? Because I hope that if you are in 12th and if you're preparing for any competitive level examination, you should know some basics of physics also. And I am not giving you the definition part that you use it to get in 10th standard. Write the definition of this one, and your teacher was dictating you something, like, and you are writing something. But now you're in 12th. I think that you're in grown up child now. You don't need the definition part. So that's why we are in the speed now. I am giving you the derivation part, which one is important for your examination. Then we are taking the exceptions part, the numerical. So based on this particular speed, in next 3 days we will complete this chapter. Then it will take 1 week or 4 to 5 days for capacitor. Then we will start this one. I guess from next Monday we will start magnetism. Okay, because maximum numerical probabilities or possibility from combination resistor, na, you will find it very easy now. Why? Because in sorry, capacitor, because the capacitor part and the resistor part is somehow similar to one other. That's why I took firstly the resistor, second part we will take the capacitor now. You can mark your thing. Next week we will start the magnetism part. Magnetism will take 10 to 15 days or minimum 10 days. Then we have AMI AC. Then we have EM waves 1 day. Optic is 15 days. Then we have semiconductor. We have done dual nature that will take 5 to 6 days. Atom nuclear 5 to 6 days. Before September, we will complete the whole syllabus. With this particular pace, we will complete the whole syllabus. Then after completion of 12th, we will start 11th standard for your NEET or JEE 2026. Okay, I will start these lectures and the series. And I was thinking that I will start the basics of foundation courses as well. I was thinking, no, sir, you had taken PCM. Yeah, in my back days. Yeah, I am from NIT Srinagar. Yeah, I am student of PCM. Yes. I'm an engineer, right? So I guess we have discussed enough things. So just take care, take some rest. Tomorrow you need to go to school, no? And I have to take them classes for my industry also. So, beta, thank you, beta. Take care. Bye. Good night. I guess you know me from my previous institute, no? We'll talk there about it, okay? Okay. Thank you, beta. Thank you. Thank you. Thank you. Thank you. Thank you very much. Bye. Thank you, Hasna, beta. Thank you. Bye. Good night. Take care. Bye.